Hi, this is a short tutorial on how to solve pressure-volume problems. Pressure-volume, the relationship between pressure and volume is indirect. So it's a little bit different than the other two that we've talked about. A 30-liter balloon with a pressure of with unknown pressure is expanded to a volume of 90 liters and a pressure of 6 atmospheres. What was the original pressure? They're looking for the original pressure, so I'm going to go ahead and mark it with an X right away, and then fill in the rest of the numbers. So I know that the initial volume of the balloon is 30 liters, and we're expanding it until it gets to 90 liters and has a pressure of 6 atmospheres. Okay, so indirect relationship means that the variables behave they basically behave in the opposite manner of each other. So that means that if the volume went up in this case, the pressure has to go down. And what that means is that the original initial pressure, the one that we're looking for, has to be higher than the final pressure of 6 atmospheres. So let's see how that's going to work when we're doing the math. We're going to set up our for every statements. I don't have a whole lot of room up here, so I'll just go ahead and do it on the bottom here. So for every x or blank, there is 30 liters. And for every 6 atmospheres, there is 90 liters. So we're going to look at the volume first, and I see that the volume increased by a factor of 3. So that means I had to have multiplied 30 times 3 to get the 90. Since it is an indirect relationship, instead of multiplying the other set of variables, we're actually going to divide. Okay? So you're going to change that sign to a divide because it was multiplied here. We're expecting the x to be higher than the 6 because the initial volume was lower than the final volume. So since I'm dividing x by 3 to get 6, I can just work backwards and multiply 6 by 3 to get 18 atmospheres. Okay, 18 atmospheres is my final answer in this case. How will the PPs work? Well, let's take a look at this. We are going to follow the same rules for particle pictures as we've been following. So we're going to first draw the volume, then number of particles, then temperature, and then pressure. Okay, volume first. Since volume changed from the smaller to bigger, I'm going to draw 2 different size boxes. Number of particles doesn't change, so I'll go ahead and just use, I can fit 2 in here, maybe 3. Put another one in here. Okay, so number of particles doesn't change. I'm going to keep it constant. And then the next thing we're going to address is the temperature. Temperature did not change either, so I'm going to do 1 whooshy on each particle. Okay, and just like we've discussed, volume and pressure are indirectly related. So when you think about it, the one that has a smaller volume should have a higher pressure. And it makes sense when you think about it. If the particles don't have a lot of room to move around, they are going to be colliding with the walls of that container a lot more often. So I'm going to show 2 particles bouncing off the walls in that smaller container, and just one particle bouncing off the wall in my bigger container. So we've addressed temperature and pressure, and we're done. Thank you.